So the profit function, 4x squared minus 6xy plus 3y squared this is negative. This is positive because I have to subtract the cost. This is negative. I have to subtract the cost. Good. 18x minus 20x. 25y minus 19y. And plus 12. One more time. 18x minus 20x is negative 2x. 25y minus 19y is 6y. But minus this, opposite of this, opposite of this, and opposite of this. This is the profit function. So now we want to find the maximum. I have to find px, I have to find py, and so on and so forth. Px, negative 8x plus 6y minus 2. Py, 6x minus 6y plus 6. Now pxx, negative 8. Pyy, negative 6. Pxy, 6. Pyx, yes, 6. Good. This is good. So now I create the system, only with px and py. It's like the critical numbers from before. Negative 8x plus 6y minus 2 equals 0, and 6x minus 6y plus 6 is 0. Okay, very good. When I add the equations, these two go away very nicely. Negative 2x, and this is plus 4 equals 0. I move 4 to the other side and divide, and I get x equals 2. Now, we want to plug in 2's to find y. So 2, negative 16 plus 6y minus 2 equals 0. So this is negative 18, move to the other side. 6y equals 18, y equals 3. So the point in discussion is 2, 3. We need to find d. Pxx at 2, negative 8. Pyy at 2, 3, negative 6. Minus pxy, 6 squared. So, what was it? Yeah, correct. 56 minus 36, positive. And pxx is negative. Therefore, 2, 3 gives a relative max. Oh, what did I do here? It's 6 times 8. Sorry. Good. Positive. 2, 3 is a relative max. And P of 2, 3 is okay, negative 4, 2 squared times 4 plus 2 times 3 is 6, 6 times 6, 36, minus 3 times 9, minus 4 plus 6 times 3, 18, and plus 12. with your permission, I'll just calculate. So negative 16 plus 36 minus 27 minus 4 and plus 30. What did I get? 19. So this function, the profit function, has a relative max when 2,000 of x and 3,000 of y are produced and sold, and the relative maximum is 19, and I'm assuming is 19,000, although they didn't say anything about the revenue, but I'm assuming that that's what it is, 19,000, because the cost is in thousands. So this should be 19,000. Any questions? How do we feel about this? About the d-test? Okay, nobody says anything, so I'm assuming that you're okay. Any questions? Anybody? The very last section, as I mentioned, is only with a calculator, and it deals with the least, which is minimum, square technique or method. What does this mean, and why is it here? Well, every time we talk about minimum or maximum, we talk about calculus. And it has two variables. So we're trying to find the minimum error of fitting a line through a cloud. Okay, I said just a lot right now. So let's suppose the following example. I have, let's say, 10 students, and I collect on each and every student height and weight. This is an ordered pair. So on student 1, I have H1, W1. On student 2, I have H2, W2. And on 10, I have H10 and W10. All these are ordered pairs. So when I plot these ordered pairs, so here's the height and here's the weight, let's say the cloud called scatter plot looks like this. These are my points. It kind of looks linear. I want to determine the best fit, the best line that has the minimum error. And this is called the linear regression line. Linear regression line. Why is this in this chapter again? Because we're talking about minimum, finding the minimum error of the squares. So how do I determine this given a set of ordered pairs? First of all, I will plot them to see if the trend is linear, either with a positive slope or negative slope, because if it's like this, that's quadratic, it's not linear. If it's like this, it's exponential, it's not linear. So I have to see the scatter plot first, and then I will fit or give the calculator the command to fit the best line that may help us predict. That's what the whole thing is all about. I want to determine this line to predict, not too far out of the data, but to predict trends. So let's take a look at an example, and I want to show you how to work these problems with a graphing calculator. So this is on page 582. Okay, so let's say we have find the regression line for each data set. You do not have to worry about the exponential regression, just the regression line. So let's say I'm gonna choose 2. So let me better just, we can go to directly to a word problem. Here, they're all the same. Life expectancy of men. Consider the following. Find the regression line and use the regression line to predict the life expectancy of men and such and such. Okay, so first I'm going to just copy the data because I want to put in the graphing calculator. 0, 2, 5, 7, and 10. And then 74.85, 75.10, 75.90, 76.18, and 76.33. Okay, so with the graphing calculator, I go to Stat. I want to edit. I will be editing 2 lists. I'm editing list L1, highlight, clear, and list L1 is 0, 2, 5, 7, and 10. 0, 2, 5, 7, and 10. List L2, 74.85. Do not change the order. They have to be exactly as we have them. 75.10, 75.90, 76.18, and 76.33. Good. Now, see the range here, 0 to 10, 74 to 76. So I have to adjust the viewing window. 0 to 12 is fine. 50 to 80 is fine with a scale of 2. And now we go to second and stat plots. Second and stat plots. I turn it on. This is the scatter plot. I prefer blue. It doesn't matter. You can choose any mark you like, any color you like, and just press graph. Now let me check and make sure that I deleted that because it would be in the way. Really? What did I do with the window? The calculator was right. Here it is. It kind of looks linear. So what I'm going to do next is go to Stat. This time I want to do calculations. And I want to choose number 4, linear regression, slope times x plus the y-intercept. So I'm choosing 4. List L1. Where is my list L1? I lost list L1. Here it is. List L1, yes. Yes, I want to store the linear regression into, okay, 4. I want to store it in variables. Where are my variables? In y1. Okay, and now calculate. Here it is. So the linear regression line is y equals a 0.1613, x plus b is 74.897. Good. Now you can already see it. It's already entered. Here it is, because I asked the calculator to enter it. And now look at the graph. So I have the scatter plot, and I also have the linear regression line already graphed. Now, they are saying, use the regression line to predict the life expectancy of men in 2025. X is the number of years since 2004, so I have to plug in 21. So when I go to second and table, I will plug in 21, and I get 78.2. So add X equals 21, which is 2025, Y equals 78.29 years. This is the end of the course. There are no more new topics. What we're going to do for the rest of the time, we're going to read